living the physics.
Newton's third law. Law of action and reaction.
With every action occurs whenever an equal and opposite reaction. In other terms, the mutual actions of two bodies are always equal and oppositely directed. Isaac Newton was an English physicist, philosopher, theologian, inventor, alchemist, and mathematician, author of important theories and foundations.
He described the universal gravitation and laid the foundation of classical mechanics with the law that are called all with his name: first, second, and third Newton's law.
Newton's third law, or law of action and reaction, corresponds to the last of the Newton's laws. It is completely original, because the first two had already been proposed in other ways by Galileo, Hooke, and Huygens, and makes mechanical laws logical and complete.
This law states and exposes that for any force applied on a body, this will produce another force equal in magnitude but opposite in direction on the first body.
It is named action force, which is exerted by the first body that causes a force on another. Therefore, is called the reaction force, which is caused by the body that receives it and reacts with this other force on the first body.
These two forces have the same magnitude regardless of weight, mass, or size of the interacting bodies.
It is important to have in mind that the principle of action and reaction involving two forces is applied to two different bodies. The materials should include two plastic bottles, duct tape, an air pump for bicycle tires, water, a piece of hose from around 0.3 meters, and some elastic string. To perform this experiment, what we have to do first is to build our bottle. For that, we must cut the top of the second bottle and attach it with the duct tape at the bottom of the first one, creating an aerodynamic front end. We also must join the hose with the pump hose using the elastic string, and using more of it to roll it at the hose until its size approaches the one from the bottle. Then, a person must insert the hose into the bottle and the other one should start pumping and the air pressure will build up. The first person must hold tightly as much as it can. The more air it is possible to accumulate in the bottle, the bigger the height it will reach. When the bottle starts to accumulate air, since liquid water cannot be compressed, it is the air which is compressed considerably, increasing the pressure of the gases, so that when released, the bottle expels gases at the bottom hole at high speed, driving out the water. This is precisely the action. The reaction, therefore, is the impulse received by the bottle, which will drive it into the air. In conclusion, we notice that Newton's third law states that there can be a single isolated force, but rather the forces in nature always exist in pairs.
The action force is equal in magnitude to the reaction force and opposite in direction. In all cases, the action and reaction forces act on different objects.